Okay, this is 10. Last time we talked about triangles, which is essentially straight lines. Any kind of polygon you can do it with triangles because, any kind of polygon you can do with triangles because basically they're just triangles that put together. So this is the triangle. So you got anything four side. This is four side. So this is 180 degrees, all these angles. So this is another 180 degree. You want another side, that's another 100 degree, another side, another 100 degree, so on and so forth. And any kind of study of this, any kind of a shape, as long as it's straight lines, you can use triangle knowledge to really get to it. Mm-hmm. Yeah. For instance, last time we had a parallelogram, right? Which means you have a shape that's all parallel. Mm-hmm. And to study that, you can, for instance, draw a line like that, because this is this is parallel to this, so this angle equals to this angle, and also because parallel, this angle equals that angle, and these two triangles are similar because they share this side. They are congruent. Once they're congruent, all the sides are the same, and then you can get all the other properties. One thing that when you go about proving things, you need to make sure that all the known facts are used. Mm-hmm. For instance, when this angle equal to this angle, you're using the fact that these two lines are parallel. This equal to this, you're using the fact that these two lines are parallel. When you do a problem, if they give you one condition you never used anywhere, you gotta be careful about that. Normally people don't give you problems that one of the condition they give it to you is unnecessary. But anyway, so today we're gonna do another type of shape. There are only two types of shape that we're dealing with. That is a circle. I'm going to draw a circle. The first thing you need to know about the circle is that any kind of angle riding on the same arc, which this angle rides on this arc, right, from here to here. Yeah, from here to here, right? Any kind of angle, angle riding on this arc is the same. They're congruent. The measurement is the same. You draw an angle like that, right? Mm-hmm. Say this is whatever, 40 degrees, then this angle will be 40 degrees too. And that angle will be 40 degrees. Any of those angles are 40 degrees. Okay. We want to prove that. So let's say here is the center of here's the center of this circle, and then we draw these lines. This line. Okay. Okay. Actually, this angle is half of this angle. This angle is half of this angle from the center looking at the same arc. If I can prove this angle is half of this, I proved that, because this point can be anywhere, right? Yeah. Yeah. This is when you prove things, you want to make sure that well, first of all, when something is hard to prove, you look for ways to prove it. but you want to make sure it's actually equivalent. Let's just call this alpha. Then this is alpha because this is a same triangle, right? Do you know we'll call this beta? Just beta. These two angles are the same. Do you know why?
No.
When a triangle, when both sides are the same, when there are two sides the same length, and then these angles are the same. Well, anyway, you can imagine it, right? If it's the same angle, then they are symmetric. Say it's the same angle. We draw this, right? You want to call this alpha, call this beta, let's say, yeah? Call this beta, right? This equals to this. Right? All you need to do is drop a perpendicular line down. Okay, these two triangles, they have a perpendicular line, share a perpendicular line. They share this line, and this is the same length.
Yeah.
So these two are congruent.
Yeah.
When they're two congruent, alpha equals to beta.
Yeah.
Yeah, I just prove it to you. So now we call this gamma, okay? This angle, we'll call it theta. This angle equals to, theta equals to 180, or just write pi to get used to the way of writing in radian. It's 180 degrees pi minus 2 beta, right? Because these three added together is 180 degrees.
Yeah.
Okay. Now,
wait, pi?
Pi is 180 degrees. Remember? Okay. When you measure an angle, one way to measure is you call this 360 degrees.
Yeah.
You separate into 360 equal parts.
Yeah.
That's random. But we want to have another way to measure this, which is the length of this arc. Length of the arc. When you have an angle, right? The angle faces an arc, right?
Yeah.
We say this arc divided by the radius. Let's call this radius 1. We draw a circle with the radius 1. So you divide it by 1, doesn't matter, right?
Yeah.
So the length of this arc, right? We just call that equal to the angle. That's one way to measure the angle. Okay?
Okay.
So this the circumference of a circle is 2 pi.
Yeah.
Yeah? So 180 degrees is pi. Yeah. 90 degrees is half pi. Make sense? Yeah. Okay. So this makes sense, right?
Yeah.
Yeah. This is essentially just a different angle. I mean, different unit. It's like you have a pound and then you have a kilogram. Same thing. Different measurement. Okay. We want to get to the relationship of theta and alpha plus gamma, right? Alpha plus gamma, right? That's this. Okay. Alpha plus gamma, we know that, let's see what we know. We know that 2 alpha, we know this, in this big triangle, right? 2 alpha plus 2 beta plus 2 gamma, that's 180, right? Let's see what we can do with this. From this one, we have 2 beta equals to pi minus theta. Yeah? We move the 2 pi over, we move the theta over. Make sense? We'll move the theta from this side to this side, become minus this.
Yeah.
Yeah. Right? And we'll substitute this in. 2 alpha plus pi minus theta plus 2 gamma equals to pi. Yeah? That makes sense?
No.
You substitute this into this.
Yeah. Okay.
Okay, and pi cancel out, right? Move theta over, so theta equals to 2 alpha plus gamma. We move the theta over, then become positive.
Oh yeah.
And then we take the 2 out, become this. Yeah?
Okay.
So theta, which is this angle, is equals to 2 of this alpha plus gamma.
Oh.
Make sense?
Yeah.
At this point, you can draw it anywhere. It doesn't matter. And you can do this, actually, if you draw this way, right? When you're out, over on this side, the triangle look a little different, but it's the same thing. And now we have that. That's a very important. By the way, last time we went through a lot of triangle stuff.
Yeah.
And those are let me see if I can find one. Those are some of the pretty important. You may call it properties or whatever of a triangle. For instance, this is the middle point you're drawing over. This is 2. This is 1. This is 2 to 1. This is 2 to 1. You know, that kind of relations. You want to go through this stuff enough so this becomes to sort of you almost remember it. But of course, when you're doing it, you're trying to get the way of proving this stuff. I'm gonna give you some problems so you can go about proving it. Of course, these are kind of harder ones. This is not hard actually. You can do this one, and also also if you draw a let's go to this. If you draw a tangent line here, okay, this angle also equals to this angle. Can you see that?
Yeah.
Remember last time we say we move off this a little bit. We move off this a little bit. That line is going down the tangent line, right? Because you move off just a little bit, and that angle that's already that's out there, right? So this angle is that angle, and that angle equal to any angle, riding on the same arc. We're doing this to prepare you for calculus. Let's say you have a circle, right? Right?
Yeah.
And then you have this is the arc, and then you have a tangent line, right, going through this, right? This is a tangent line. You imagine this. There's an angle like this, right? When this point goes so close to this point, this line becomes this line, and this line becomes this line.
Yeah.
So this angle equals to this angle, and then it equals to any angle that rides on this. Any angle that rides on this arc. Yeah, that makes sense? Very often we think very, very short. Also, for instance, that line, you can think it's a straight line when it is infinitely close.
Okay.
Yeah? That's what we're saying. It is circle a zero polygon with 0 sides or infinite number of sides. You can say infinite number of sides. Because when you look at infinitely small segment of it, you can treat that as a straight line. Okay. Actually, pi is calculated. You can use computer to calculate the pi. Okay, now let's look at this. You have a circle. This is very challenging because we draw a lot of circles and I'm very bad at it. Okay, you have a diameter. Let's call this diameter, right? Then you have an angle. You have you have 2 lines that rise on this. What can you say about this angle?
This angle?
Uh-huh. look what we just did about this. What about this angle and that angle?
That's not that angle.
Well, look at this. Here's the center, right?
Which angle are you talking about?
This angle is twice this angle. That's what we just proved, right?
No, in this one.
Oh, what can you say about this angle? You give up?
Wait.
It's 90 degrees. Because look, this angle is always twice this angle, right?
Yeah.
When this is a straight line, what's this angle?
180.
Yeah, and then what is this angle? This angle is half of this angle. Yeah?
Mm-hmm.
It's kind of obvious, right? After I tell you, it's obvious, right? But this is very useful.
Okay.
This kind of knowledge is very useful in proving anything. We'll go about proving things, and that part we're not going to do it over the video because mathematics is like swimming. We're talking about the theory of swimming, which doesn't mean much. Whether you're good at math is really whether you can swim or play tennis or volleyball, whatever it is. It's whether you can do it. And now we're talking about the theory of playing tennis. Everybody can talk about theory of playing tennis.
Yeah.
Can watch Roger Federer doing it. But whether you can actually go do it, that's a totally different matter, right? Okay. But anyway, we're moving along. This circle is too small. Anyway, we say an angle that's riding on the segment, this segment, right? We have another angle riding on the same segment. Okay, I'm gonna name this. This is A, this is B, call this O, call this C, call this D. You know, we know that these two triangles are called OAB and OCD. These two are similar, obviously, right?
Yeah.
Because this angle equals to this angle, and this angle equals to this angle, or whatever. You know. Oh, by the way, these facing angles are always the same, right?
Yeah.
One way to prove it, obviously, is this is a straight line. This is 180. This is a straight line. This is 180. Then the both angle out of this at one angle, that's the same.
Mm-hmm.
Yeah. Okay. Anyway, now we can write some conditions, write some things. The segment that facing this line is OB. OB divided by OC equals to, for instance, this segment, right? OA, OB also equals to AB, DC. This doesn't look that, whatever. Wait a minute. OB to OC is OA to OD. Oh, yeah. Okay. This is OD. Okay. This is obvious, right? Because these two triangles are similar,
Yeah.
then the sides are all proportional.
Yeah.
Now, we multiply this. Then you see something kind of interesting. OB multiplied by OD, right?
Mm-hmm.
Equals to OA multiplied by OC. That OB multiplied by OD
Yeah.
equals to OA multiplied by OC. That's interesting, isn't it?
Mm-hmm.
And this situation you can expand it to like this. You can expand to this. If this point is outside, by the way, this point doesn't have to be the center of the circle, right? Just any point. If you put this to be a point outside, right? We can have, let's just call this C. This is A. This is A prime. B. This is B prime. Right? We can say CA prime equals to CB prime. Okay? Can you point out the two triangles that's similar here? C
A prime B
CA prime B, yeah.
and CA B prime.
Right, because this angle is the same, right? And yeah, this is the shared angle. Then you do the side, the CA, which is the short end, divided by CB, equals to CB prime, which is the long end, divided by CA prime.
Yeah.
Of that triangle. Okay. You have a circle, right? You have a tangent line, right? You draw the diameter over the tangent line. What can you say about this angle? Okay, whatever.
It's 90 degrees.
Okay, why?
Because there's a square thing there.
Well, yeah, because this angle is looking at half of the circle, right? The half the circle is, this is 180, and then so half the circle is 90. Yeah. Okay. Okay, I'm not going to do too much on this. Let me see. Yeah, I'm not going to do too much on this. Before we go through some of the problems. Okay, we're gonna, this is about circle. We're gonna stop here.